I want to talk about containers. If you're doing the container drinking game at Velocity, I assume you're already pretty well drunk. And if you're not bombed out of your mind, you managed to crawl in here this morning, you may want to fill up your drink, because we're going to be doing a lot of containers. It's going to be container, container, container all the time. But for that, let's turn the history dial back, as I am wont to do. Let's look at container prehistory. Where did containers come from? And containers, and actually the great thing about containers is kind of like the mystery of the world. We don't totally know. So containers emerged with Chroot, with BSD back in the day. So Chroot, if you've used Chroot allows you to have a directory in a file system, and to have this directory act as the new root directory. You virtualize the file system in effect. And it sounds like a great idea. Where did it come from? Well, we know that Bill Joy put it back. We know that Bill Joy, according to the SCCS history, Bill Joy put this back on March 18th, 1982. We don't know why. And when I say we don't know why, Kirk doesn't exactly know why, and I don't think Bill necessarily knows why. And it's like, it's the 80s, it's Berkeley. I mean, the odds of Bill Joy being able to pass a drug test immediately after having pushed this into BSD are infinitesimally low. Certainly THC in the system is not something much more psychoactive. And I don't know if he did this because, Kirk hypothesizes that he is trying to build 4.2 BSD on an older system and is trying to virtualize it for that reason. Maybe that seems plausible, seems good enough. Maybe he was doing it because the leprechaun was threatening to kill his family if he didn't. We just don't know. What we do know is that this is a very good idea, that Chroot was a very good idea, and that people began to experiment with this idea, and in particular as a way of running untrusted software. That I'm going to grab start the countdown timer. If we don't, I will just go on all day, actually. Wow, I managed to consume only nanoseconds. Exactly. Give me the hook. This is a very good idea, and people in particular were using this to actually contain untrusted software. I'm going to run untrusted software, and because I don't want it to break my file system. And so that makes sense. And indeed, some folks wanted to take this to its logical extreme with jails. And people know jails from FreeBSD. This is one of those things where it's like the name is all you need to know. It's a jail. We're going to incarcerate this application. I think they stopped just short of calling it a prison. I think prison would have felt like your application is going to get shivved in the shower if we call it a prison. It felt too visceral and real. But it's a jail. It's like a happy spaghetti western kind of prison. You go to jail. Do not pass go. Do not collect $200. But your app goes to jail, and it is confined. And it is rigidly confined, and it is explicitly for security. So what they've done is they've taken Chroot, because Chroot had a lot of escapes. In particular, you could cd ... out of Chroot. It's like, okay, that clearly, drug test, please. Can we order the drug test? You could cd ... out of Chroot. So there were some obvious ways to get out of it. There were some more subtle ways to get out of it. So with jails, they took Chroot to its extreme, from a security perspective, and created what began to feel more like a virtual machine, but wasn't really designed to do that. Jails were really designed to confine and run untrusted software, in particular software that you downloaded off the internet. Mailers did this a lot, right? Mailers used Chroot a lot, and they were using jails a lot as well. So in the internet age, this was great as a way of running untrusted software, and a great paper from the late 90s from Robert Watson and co. describing it. We saw this at Sun. I was at Sun for 14 years back in the day, and wanted to take this to truly its logical extreme with zones. So jails were great for confining. We loved the confinement aspect of it, but we also saw, actually, this is a great way of virtualizing an entire operating environment, because the observation is that an application had grown more complicated than just a binary. It used to be way back in the day that an app was just a binary that you either downloaded or more frequently bought and ran. Apps got way more complicated. They became the entire operating environment. They grew dependencies on particular database servers or web servers or what have you. They became more complicated. And what we saw was this idea that was pioneered with jails was a way of actually consolidating many of these apps on a single big piece of iron, which is what we wanted to sell you. I mean, that's the bit we don't tell you. It's like, psst, it was to sell you a very expensive piece of hardware. It's like, why would anyone pay that much for a single piece of hardware? It's like, well, actually, funny story, they didn't actually. That's, anyway, let's not go there. But the idea was very sound. And actually, if you take away one thing from this talk, it would be to go look at this design document circa 2002, virtualization and namespace isolation in Solaris. This was the project that was originally named Kevlar. Hint, do not codename your project with what is clearly a synthetic trademark name. It's like, yeah, we codenamed this project McDonald's. It's like, okay, well, we can't call it McDonald's when we ship. You realize that, right? It's like, why can't we call it McDonald's? You're always trying to tell us engineers what to do. It's like, no, we can't. They actually have a point. We can't call it Kevlar. Anyway, so we call it zones. But this design document is a terrific document, surprisingly prescient, actually. And I would really recommend, you can Google it pretty easily. I recommend that you actually take this part and actually read it. It was back in the day when people used to write about what they were doing before they did it. It was kind of a funny idea. And worth checking out. And and zones were terrific, and they worked great. And the goals outlined by zones in that document, security first and foremost. And this is the grand irony of containers, that the security was a constraint. They were born out of security with jails and zones. Security, isolation, virtualization, granularity, and transparency. Transparency kind of strangely named, but transparency, the idea that you're running the same operating system kernel across all of these zones. One OS kernel, a different app environment, these things run very quickly and so on, but not among these goals, running foreign binaries or emulating other operating systems. So this was great for selling Big Iron. Well, okay, the Big Iron did sell, but it was great for consolidating many applications. It was really not so great for consolidating Windows. And that's what the world wanted in 2000. What we had in 2000 is because and admittedly, Bill Gates robbed me of my childhood, so I'm of that generation. So just when I throw Microsoft under the bus, and that feels mean-spirited now that they've like open sourced everything and they're like the happy Microsoft, understand that I grew up under the evil Microsoft, under the findings of fact Microsoft. Anyway, so I'm sorry, I'm of that generation that just won't buy a Windows Phone out of point of principle. But fortunately, there are enough of us that Windows Phone actually died, so there you go. But yeah, Microsoft, okay, big group hug, fine. Everything's all better. But the fact remains that Windows itself was terribly designed to run multiple workloads circa 2000. And what you had is a bunch of physical sprawl. People had physical machines running a single Windows service, a single app on a physical machine, which obviously made no sense. And what the world wanted economically was to be able to consolidate that onto a smaller number of machines. Clearly, these things are not soaking up an entire spindle. And for that, if you want to run Windows, you want to consolidate Windows, zones, containers, really the wrong way to do it. The right way to do it is a very old idea, hardware-level virtualization. So with zones, with containers, you're virtualizing the operating system. You're giving everyone their own virtual system call table. It's very lightweight. But there's a deeper way you can virtualize. You can virtualize by giving everyone their own hardware. It's a much lower layer of abstraction. You're going to give a tenant their own virtual CPU. You're going to give a tenant their own virtual DRAM, their own virtual NIC. There you go. We're done. It's like, well, actually, that's a very low level of abstraction. If you want to make any of that stuff do anything, you actually need this thing called an operating system. Sorry. So you have to have an operating system that lays down on top of that. And that operating system will then run your apps. Your apps run on top of an operating system that run on top of a second operating system. But because saying like having one operating system run on top of another sounds like this sounds like large pachyderms involved in kind of inappropriate behavior. So they actually call that second operating system a hypervisor, make it sound like really lean. It's a hypervisor. It's like it's an operating system. You have two operating systems. It's just one of them. It's like the preschool versus daycare thing, right? It's like it's the same goddamn thing. It just depends if they're watching television all day, it's daycare, and if they're like off like exploring their hands, it's preschool, whatever. Same goddamn thing. So the same thing, hypervisor and an operating system are the same thing, it's just that one's at a different layer. And actually, this is a very, very, very old idea. So this idea actually does date back to the 60s. And it's kind of easy to be like, oh, it dates back to the 60s. People will just say this without any understanding of what actually happened in the 1960s. But it's actually, the history here is actually interesting and relevant. So the history of hardware virtualization is that there were, back in the day, the Tower of Babel, there were a million different computer companies and computers and so on, and IBM in particular had at least 5 different instruction set architectures. And in the mid-60s, IBM undertook what is still one of the most impressive computing projects in history, the IBM System 360. System 360 so named for 360 degrees of view. They were going to run everything. You're going to run commercial workloads, scientific workloads, accounting workloads, all of this stuff was going to run on the one beautiful, glorious instruction set to rule them all. It was a great time to be alive, I think. And of course, what this meant is that you were going to rewrite all of your filthy software. You're of course going to rewrite it in this new glorious assembly language, of course. You get the privilege of doing this. Well, as it turns out, people were not so into this. And when they had announced this, in particular, people that were running the IBM 1401, so there were a couple major machines, the 1401, the IBM 650, the 709, 7090, the 1620. The 1401 was in particular very popular. And there were a bunch of people running the 1401 that were actually not so into rewriting their software. And to me, this is amazing, because the years like 1963, 1964, and already software is like 8 nanoseconds old, and already it has a greater inertia than hardware. That actually my software, I don't actually want to rewrite it. This is kind of amazing, right? So IBM's like, well, too bad, you're going to have this glorious experience whether you like it or not. And people are like, no, I'm not so much concerned with this. And then Honeywell came into this gap. You're like, Honeywell, like the thermostat people? Yes, the thermostat people. Do you know why? It was the 60s, and everybody was a computer company. It was like Oprah for a computer company. Like, you're a computer company, and you're a computer company. Everybody's a computer company. Singer was a computer company. It's like, the sewing machine people? The sewing machine people. Bendix was a computer company. Like, the brake people. The brake people, yes. What do these things have in common? Absolutely nothing. They're all computer companies. So anyway, Honeywell, the thermostat people, they're making their own computer called the H200. And the H200 was going to be its own crazy instruction set, and they had a very good idea. What if we made an H200 look and feel and smell like a 1401? And what's in software make an H200 look like a 1401. And that's what they did, and they called the software, is just like, this is where I really missed the Cold War. The software was called the Liberator. It's like, come on, you gotta miss the Cold War. I mean, if a Liberator is not the name of software, it would be the name of an ICBM. You know, it's like, this is like classic kind of Cold War thinking. Anyway, they had the Liberator, and the Liberator allows them to run 1401 software on the H200. The H200 takes off. IBM sees this, and they actually invent a virtual machine architecture for the 360. And that virtual machine architecture in the 360, and then in the 370, and so on, that virtual machine architecture becomes a very important part of our ecosystem. So that idea was a very important idea. And actually, funnily enough, I was actually in New York after Y2K having a conversation with a CIO from a very major bank. And in terms of the footnote to this story, and the CIO tells me, you know, it's funny, 45% of our Y2K problems came from a single hardware architecture. I'm like, go on? The IBM 1401. The IBM 1401, a machine that is old for my dad. And I know I look like Doogie Howser or whatever, but honestly, I'm old at this point. Like, I have 3 kids. Like, one of them is like an annoying preteen. Like, I'm old. My dad is really old. The 1401 is extraordinarily old. The fact that like that software is still running in production in 2000, mind-bending, and shows the persistence of software. Anyway, amazing. But so if you want to run 1401 software until the heat death of the universe, dial up some hardware level virtualization, man. This is great, great, great stuff. But it cuts against you in every other way. You have that second operating system that we call the hypervisor, or the guest operating system. That second operating system. It's like, does that not make things faster? You're right, it doesn't make things faster. You don't make things faster by adding another operating system to the mix, right? It slows you down. It's worse though than that. It degrades tenancy. You think about things like DRAM. The hypervisor's got a physical machine that it's running on. The DRAM that it wants to give to a guest, to a tenant, that DRAM is gone. It has no way of knowing how that DRAM is actually being used. And you think, like, right now, when you go provision an EC2 guest on Amazon, you ask for 2 gigs of DRAM, you get 2 gigs of DRAM. The hypervisor does not know how that DRAM is being used. Are you using all of it? Assuredly not. Right? You are doing what we have always done for time immemorial. You're doubling the estimate that the other person gave you. So the amount of DRAM that's being used, you can actually like infer something about organizational patterns by the amount of DRAM that's actually being used. Because everybody is doubling everyone else's estimates. And if it goes through like 6 people, that's 6 doubling, that's a lot. It's like, wow, this is a 64 gig VM for like a Go process. It's like, well, we've got a very complicated organizational structure. It's like, all right, that does not make any sense, but fine. And it reminds me, we were in, was working with some peers we were at Sun, we were kind of doing a startup within Sun, working in this kind of Class C office space that we love dearly, and we had all resigned ourselves to the fact that this thing was going to totally collapse in any kind of seismic event. This is where my wife is like, why do you say seismic event? Don't you mean earthquake? Like, yeah, but earthquake sounds so non-technical. It's a seismic event. Anyway, it's like, is this why you use non-trivial? It's like, yes, this is why I use non-trivial. It's not difficult, it's non-trivial. She's like, why did I marry you? Why, whatever. So in the event of a seismic event, we were convinced that we were going to be a pile of rubble. And we were talking to a contractor who's doing work, and I'm like, well, we think we're going to die in an earthquake. He's like, actually, it's funny. In this building, you are about as safe as you can possibly be, because that particular building was built in 1920. And in 1920, the city had burned to the ground only 14 years prior. And everybody was like quintupling everyone else's estimates. So by the time you got to the final end, you could drive a Buick into your office space and across a floor and park it there, and then do that a couple more times and be just fine, because those buildings were so ridiculously over-engineered. We've done the same thing with DRAM. With DRAM, we've over-engineered our DRAM because, by the way, running out of memory is still a very pernicious problem. Two problems we're never going to escape in this business: running out of memory and running out of disk space. It's like, these are two of the nastiest problems in IT, right? And yet we are still dealing with them, and we will always be dealing with them. Because running out of DRAM is so bad, we double and triple and quintuple our estimates, and what you end up with is a bunch of DRAM that's not being used. This is where is it melting the ice caps? Well, I don't know, but it's actually emitting greenhouse gases. I mean, you're emitting greenhouse gases to be refreshing a capacitor every 79 nanoseconds that actually is containing nothing. It's containing nothing but paranoia, right? Albeit probably well-placed paranoia. So this is the problem with hardware-based virtualization, is that the abstraction is so low that the actual machines are grossly underutilized. Underutilized from what that can actually do. The problem is, if you actually go onto one of these machines that's running a bunch of hardware virtualization, you look at the physical machine, you'll see that it's working really hard even when it's doing nothing. Because you have a bunch of guest operating systems that don't know how to do nothing. And trust me, I understand this. Like, I've done OS development my entire career. It's like, you can't tell an OS to do nothing. It's like, I'm on the hardware. Like, if you've got nothing for me to do, I'll just go off and do something else that I want to do because I'm running the hardware. It's like, you're actually not running the hardware. It's a lie. It's like, no one told me that lie. It's like, well, yes, virtualization, as it turns out, is a euphemism for pathological lying, but we didn't bother to tell you that because we need to be able to run you. Anyway, it cuts against you in every conceivable way. So hardware-level virtualization makes sense for 1401, makes sense for Windows, does not make sense for modern apps at all, and yet that's what we're all doing. When you deploy on Amazon, it's 100% hardware virtualization. When you deploy with VMware, it's 100% hardware virtualization. And that's not a criticism, that's just a statement of fact. So hardware-level virtualization has become de facto in the cloud. Now, from Joyent's perspective, so I'm the CTO of Joyent, we've actually been running OS containers in the cloud for a long time. So for a story that's way too long for right now, but it did get me censored, as Bridget pointed out, the operating system was open. Solaris was open, became Open Solaris. Joyent lunged at Open Solaris and deployed containers in production. We were using FreeBSD jails prior to that. Deployed Open Solaris into production using containers everywhere. Then Oracle invented a new verb when they reproprietarized. I'm like, I don't know, how do you take something closed? Like, this is like new shades of asshole that no one knew existed. So they reproprietarized the operating system, but fortunately the community was vibrant by that point. So SmartOS is an Illumos derivative. We've run it in production for a very long time. We've run containers in production since 2006. We actually added support for hardware-based virtualization in 2011, and actually, it was, for me personally, adding the support for hardware-based virtualization gave me more conviction than ever before that it is the wrong way to build de novo apps. I've been inside the sausage factory. I've built the sausage factory. Like, I've seen the number of workers that have just disappeared and the tang that's added to the product. Trust me. Like, if you're lucky, there's a lot of vermin that's gone missing too, and like shoes and bolts. That sausage is not something that is fit for human consumption. And so we came out of that more strongly believing than ever in OS-based virtualization. They're lightweight, they're efficient, you get great tenancy, and so on. But we were alone. We were alone. We believed in it, but a lot of people either didn't or didn't know about it, and we were kind of alone. Some, however, did see the power of containers, and in particular, as the foundation of a PaaS, a platform as a service. And a bunch of folks that were developing a platform as a service saw the power of containers to actually allow them to develop a product more quickly, a PaaS more quickly. Now, of course, they're PaaS companies, so PaaS is a terrible business, in case you haven't already figured this out. You can build really neat things, but it's a really, really bad business, and not many folks have made it strictly as a PaaS. And one of these that was struggling, a company called .cloud, which is to say you haven't heard of for a reason, .cloud had built an orchestration framework out of containers for their product, but they were kind of flailing as a business, and they decided a terrific Hail Mary, they're going to open source everything. And that's what they did at minute, whatever it is, 2 minutes of this presentation, they open sourced their orchestration framework, which is Docker. And Docker, of course, took off. The company renamed itself from .cloud to Docker, and that was history. In terms of what is Docker, what Docker has done is Docker views containers through a totally different lens. Not through the lens of the operator, not through the lens of making things secure, making things, getting a lot of a great tenancy, great latency, and so on. Docker views it through the lens of the developer, because what it allows you to do is allows the developer to think operationally. Allows the developer to actually pull various bits into their service, whatever they may be. I mean, kind of an interesting thought question. Has open source accelerated the rise of Docker because componentization has gone loco crazy? I mean, if you were to go back 15 years ago, I mean, the amount of choice that we have today when you go build an app, there is tons of choice out there. In fact, we're being crippled by choice. Because there are so many different choices. Those choices, though, have serious operational ramifications. Docker allows you to undo that because it allows the developer to pull in whatever they need. If they want to use Clojure in the privacy of their own home, they're welcome to do so. And I know the Clojure people are very smug, so I'm really going to hear this on Twitter. But what have you, people can pick the right tool for the job, and they can pull it in on their laptop. They can pull this in to an image that works in their laptop, and then that becomes an image that can be shipped into production as a container and hydrated into production. It's a great vision, and if you're wondering why is Docker catching on, that's why. So if you're feeling curmudgeonly about Docker, I recommend that you don't, because Docker is real, absolutely. In fact, if anything, Docker is underhyped. Not necessarily Docker the company, but Docker the technology. It's a very big deal, and it's a very big deal because it's shifting the thinking. You know, I've been known to say, I've said it before, I'll say it again. Docker is doing to apt what apt did to Thar. Apt is of course the way we package things in Ubuntu, and once you had apt, it's like I'm not going to deal with Thar or God forbid CPIO. I'd be like, wow, Thar must be the most unusable utility on the planet. It's like, oh, you've never used CPIO. CPIO, it's like CPIO, line noise, line noise, line noise, line noise. Oh, I just destroyed my file system. Okay. But somehow I didn't want to say Docker will do to app. And maybe it's what Thar did to CPIO. I don't know. It allows, again, developers to think operationally. It allows images to be not just deployed, but redeployed. It allows things to be rolled back. It allows you to know what you're running in production. So there's great, great promise. And this is indeed pointing to the future of a much broader container revolution. Because now it's like, everyone's like, wow, containers. And we're like, yes, containers. Yes, we've been here for a very long, I've been at this party for a very long time. I was just going to leave, but now everyone's coming here. It's great. And now that's great, but then people are like, wow, I love containers. If only they would make them secure. It's like, no, goddammit. It's like this is where I have a closed head injury from face palming myself. It's like, no, it's like they were born secure. That is what, okay, not with Bill Joy, but like shortly thereafter, containers are secure. They should be secure. No, they're not secure in the Linux implementation. That's a problem with the Linux implementation. It's got nothing to do with the abstraction of containers. Containers must be secure. And the way we've developed in FreeBSD and so on, they've been secure. So the security concerns are not Docker per se. It's like, I love Docker, I just don't love the fact that it's not secure. It's like, don't blame Docker for a Linux kernel shortcoming. That is where the shortcoming is. And by the way, containers are like, well, so where's a Linux container? Well, whenever you want to talk about Linux container, put it in air quotes, because there is no such thing as a Linux container. You've got namespaces and C groups. Those are the in-kernel primitives, and you're left to try to cook an upstack abstraction, a container on top of that, and it doesn't actually work, or rather it can be made to work but not securely so. It's a totally different mindset. Our mindset, again, is very much around making it secure by default and so on, and running it directly on the metal. But so what people are doing is like, oh, okay, well, containers can't be secure. You're like, so I guess I'll just deploy my container in a VM. No, please don't do this. Like, my kids don't deserve to have me come home from work like this. Please don't do this. Don't deploy your container in a VM. I mean, you are fundamentally undermining the economic advantage of containers. It's like, God is angry when you're running containers in VMs. It's like, I gave them fire. Why did they just put it out? It's like, well, they thought it was too hot. It's like, oh my God. These morons need to cook their food. It's like, actually, they would rather die of food poisoning. You know what, fine. But when you deploy OS containers when you deploy a Docker host as a VM, fundamentally, you negate the economic advantage. You negate the economic advantage, and PS, you negate the performance advantage, you negate the tenancy advantage. There's got to be a better way. So our question was, can we actually make container native infrastructure? Can we take this substrate that we've built out over the years, starting with Bill Joy's acid trip, can we take this substrate and can we actually mate this to this new idea about the way containers are developed? And this would be the best of both worlds, because then you get the agility of Docker, and you get the proven production reliability, security, multi-tenancy of SmartOS and SmartOS containers. But there's some obvious obstacles. Obstacle number one is like, well, you got the whole Linux thing, right? There's that. So we're SmartOS. SmartOS is Unix, but it's not Linux. It's like, oh, what's the difference between Unix and Linux? It's like, Daddy, what was Vietnam? It's like, oh, okay, well, it's a long story, right? It starts with like Dien Bien Phu at Murray Hill. But it's a very long story in terms of the difference between Unix and Linux. But these differences are very small. I mean, ultimately, we're still talking read-write open LSeq, same kind of ideas about the way the system is built, but different actual implementations. Now, fortunately, and this is where actually it's funny because Torvalds and I kind of vehemently disagree on what the operating system is. Torvalds believes, Linus Torvalds, the founder of Linux, believes that the operating system begins and ends with the OS kernel. That's the OS. Everything else is just like stuff you're running. So like, but glibc, yeah, like glibc is just like some program, man. It's like, but don't I need glibc to run anything? It's like, yeah, well, that's your problem. That's not Linux's problem. So, and actually, by the way, it's like, so does that mean there are alternative libcs? Yes. If you really want to get kind of weird, if you want to join me, like, get like a nose ring and a tat and head out on the Linux club scene, you can go to these alternative libcs that are actually really interesting. So things like Muscle that are actually really interesting. Alternative libcs that are not glibc. So anyway, so fortunately, we actually disagree on that. And I say fortunately because what that means is if you can implement a Linux system call table, you're done. If you can convincingly implement a Linux system call table, everything up stack will just work. So it's like, wow, could we actually do that? And we actually resurrected a Sun technology we worked on back in the day for Linux system call emulation, for doing exactly this, for having a second system call table called LX branded zones. I won't go into the details, but I will show you this. This is this is now a year and change ago. This is someone running XFCE, whatever the hell that is, Firefox, Skype, on Ubuntu 14.04. And this is running on SmartOS, but running on Ubuntu 14.04 on SmartOS. And he's running actually dtrace, actually running it against Ubuntu 14.04. And we're like, wow, that seems pretty cool. That seems pretty interesting. Turns out the response was pretty positive. Some other guy on the internet. This is one of these things where it's like, please don't show my kids this tweet. My kids don't realize it, but they are waiting for the word shitballs to enter their lexicon. It's like getting shitballs in my house would be like getting bed bugs. Like that's not gonna get out. I can't actually, you can't torch that one to the ground. So please, 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 this is why I get worried because my kids are starting to watch my presentations. It's like, oh God, skip over this part. Censor this part, please. So it's a big deal. This is actually kind of even more interesting. This is more recent. This is like sumo wrestling for software. This is SAP running on DB2, running on Linux, running on SmartOS. So running on that Linux system call table. And we're just like, when we saw that, we're like, okay, mic drop, we are done. If we can accommodate that kind of morbid obesity, we are definitely done in terms of software. So I love this tweet. 9 out of 10 Linux users don't even realize it's actually Lumos. Of course, I'm like, hey, wait a minute. Is there 1 out of 10 that actually does? To which someone else responded, the last one is probably using Haskell. I don't even know why that's funny, but it is. It's one of those things like, I don't even know. I think like the Haskell's the butt of the joke. I'm not actually sure. Haskell, by the way, one of the things that's been exciting about doing this is that I've run all sorts of unbelievable software. I've suffered incalculably because when you get this working by just downloading software off the internet and seeing if it works. And so one of the things we would do when everything works, you just kind of hang out on Hacker News and wait for the latest thing to pop up. And one of the things that popped up was this thing, Elm. Have you seen this thing, Elm? And you're like, oh yeah, Elm, the mail reader. It's like, no. You can join me down playing shuffleboard with the other senior citizens. For me, Elm is a mail reader, but like, and meanwhile people are like, what the hell is he talking about? It's like, you're ranting again. So Elm it's not a mail reader. It's not a mail reader, and there's someone who didn't know it was a mail reader, software who has a language called Elm. You're like, okay, it's a language. It turns out it's this weird Haskell derivative. So I go to install this thing, and I'm like, I've done something wrong because it's installing 6,700 different Haskell packages, and it was my understanding that there was no actual software written in Haskell. But so this thing downloads all this stuff, and you're like, oh my god. And using Cabal, this package manager, and then it gets this error very deep in the brainstem of this packaging software about this conflicting dependency. And from my perspective, it's as the one who's virtualizing / lying about the system call table, I'm always like, oh my god, how have we possibly done this? How do we have a bug that is creating but fortunately, I did what, okay, you do too, and it's okay. I Googled the problem, right? I Googled the stack trace. And yes, we're all sinners. We all Google stack traces. It's fine. So I Googled the stack traces. It turns out I'm just in something called Cabal hell. Cabal being the package manager. Indeed, if you type Cabal into Google, Google's like, do you mean Cabal hell? I'm like, I guess I do. It's this is like the people that have a very clean mind in a very filthy room in terms of Haskell. Because it's great software, I guess, beautiful software, but unbelievably bad package manager. Anyway, Elm didn't install, but that had nothing to do with us. So we tackled the binary problem, and we were, okay, great, binaries are tackled, everything runs, DB2, SAP, blah, 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 blah. All right, now let's move on to the actual provisioning problem. How are we actually going to provision a Docker container? And the way Docker works, there's a Docker program that is both the client and the daemon. So if you have ever tried, and I'm going to save you some time if you haven't done Docker before, because your first step in the Docker, you're like, where's the daemon? It's no, you've already downloaded it. It's the thing I'm running on my Mac? Yes, you should run that in the server. It's okay. Yes, same program. But that program has got a ton of embedded Go-isms and Linux-isms, and we were not about to take that program and drop it into the control plane of our cloud, because that's what you need to do. When you're going to provision one of these containers, so I should just back up and say that Joint is a public cloud company. We have a public cloud. We take that software, which is all open source, and make it available for other people to run. So we're not going to take software off the internet, run it in the control plane of the cloud, because it could delete the company. Wouldn't that be funny? So we're not going to do that. So we had to find a different approach, and fortunately we were saved by one of the oldest ideas in engineering, namely the power of an interface. So I don't know, do people recognize this? If you are not English, you are permitted not to recognize this person. If you are English, you probably also don't recognize this person, but you should be embarrassed because it's on your currency. It's on your 5-pound note. This is George Stephenson. George Stephenson is a Victorian-era railroad stud. So this guy basically single-handedly built the railroads. I mean, he had so many good ideas in railroads. And in particular, one of his many, many, many good ideas was a standard gauge. So if you want to go to Victorian-era Hacker News, it's flame wars over these various gauges, with engineers claiming it's oh no, you can't pick 3. Oh my god, terrible things will happen. It's isn't this just an eighth of an inch different from 2? It's yeah, but it's a totally different editor. I mean, the key bindings are totally different. It's all right. Okay, the nerds are fighting again. So, and the standard gauge was actually very important, and just because I can't resist telling the story, in terms of the best or worst demo ever. So the first railway that actually carried passengers from one city to another was in 1830, from Liverpool to Manchester. George Stephenson had built that, had all sorts of technical advantages. Among them, it was actually double tracked. They weren't using horses at anything, they were actually using steam trains. So they're gonna have this big day, we're gonna go from Liverpool to Manchester. So they get everyone out there, they've got the Duke of Winchester comes out, everyone's out there, they've got all these bigwigs are out there, and the train takes off, and it's going from Liverpool to Manchester, and they take a break. And there's a guy who actually was a big politician, Michael Huskisson at the time, who wanted to make up with the Duke of Winchester. He was having a fight with him. So he was going to go to his rail carriage, and he was going to actually go make up with the Duke of Winchester. So he goes to go make up with the Duke of Winchester, and dual track, new invention, didn't see the train on the other track, and the train barrels into him and kills him. You're like, wow, demo over. It's no, actually, it's the Victorian era, so we're going to keep going. It's okay, great. So they end up going to Manchester. They find out that this prominent politician is dead. Everyone loses their mind. They go back to Liverpool. Okay, this actually is a disaster. But what's funny about this is they published the obituary for Huskisson, and people are reading the obituaries and they're like, wait a minute, there's a railway between Liverpool and Manchester? That's awesome! You're like, yeah, okay, that's awesome. So this literally was how people learned about the railway, was because of the dead dude. So if you think your demo is going badly, at least you're not throwing out dead politicians. Although maybe you should to actually enhance the demo stature. Anyway, that's George Stephenson. If you know this guy, you've been in the container world a little too long. So this is the best engineer you've never heard of. This is a guy named Keith Tantlinger. Keith Tantlinger worked for a Seattle company in the 50s and had the very good idea of being able to take containers and actually being able to stack them like cubes and have intermodal transportation. And to that, you needed this invention here, the twist lock. And what is actually, I think, a great kind of primordial act of open source, the patents for this were all opened. So they're licensed to all comers with the explicit idea that people could integrate the twist locks into their own devices. And they did, and intermodal transport took off. So this was key. So just like George Stephenson's standard railway was key for the railroads, Tanslinger's standard twist lock was key for containers. And fortunately, back in Docker land, we have a great interface as well, the Docker Remote API. This is one of these interfaces, so in terms of like these two components communicate with one another via an interface over an HTTP interface. And it's one of those APIs that's so good, you can feel the pain. You know what I mean? Like APIs aren't born good. They are born terrible, and they get good only out of unspeakable pain. And this API, it's versioned and so on. You can basically hear the screams. So anyway, a very good API. It's expressive, it's modern, it's robust, and so on. And what that allowed us to do is, of course, and this is where I'm just kind of a broken person, where some people see robust APIs like, well, that makes it very easy for me to build things. And it's like a robust API, and I think, I can lie my ass off. I can lie, and I can build a virtual Docker endpoint for an entire data center of compute. And that's what we've done. So what we did is so Triton is our software that takes our software for coordinating multiple machines, multiple SmartOS machines called Smart Data Center. And that's what we run in production at Joyent. That's what it's all open source. People run it elsewhere as well. And what we did is we took a Docker Remote API endpoint and added it to that software. So that whole data center looks like a single Docker host. If you run Docker, when you run Docker PS, you see your containers across the entire DC, not across the entire machine. Docker thinks it's talking to one machine. It's actually talking to a big honking computer. And when you actually go deploy a Docker container, that Docker container runs directly on the metal. You actually allocate containers, not VMs. There are no VMs here. One never allocates VMs with Triton. All Triton containers run directly on the metal. And what's interesting is the big deal about this that we discovered when we launched this, the reason that people are excited about it, is not because of the performance. You would think it's like, oh, the performance is great. It's like, yeah, performance, yeah, I love performance, it's fine. But what actually people love is not having to deal with VMs at all. Because when you are allocating VMs and then containers on top of it, it makes containers purely complexity additive. And that is wrong. Like, let's leave aside God's anger. Let's assume God wasn't angry, even though, trust me, God's angry. Even if God were not angry, it's complexity additive. And you're angry having to deal with this, having to allocate VMs. We have recreated for ourselves the physical allocation problem from the 2000s, where you end up with physical machines that aren't running very much. You end up with VMs that aren't running very much. You get the VM that's running the one container on it that you can't bring down. And so now it's sitting on 16 gigs or 32 gigs of DRAM, what have you. Grossly inefficient. And what we have found is that what people actually like to be able to do is just allocate containers. So this has been, we've seen a lot of enthusiasm for this, which has been great. We were a little bit worried about the price point because we compete in public cloud with people like Amazon and Google. People are like, wow, isn't that a race to the bottom? And actually, we've always known that it's a pretty good business. Don't tell anybody, but the public cloud's a pretty good business because actually the margins are pretty good. And Amazon pulled the greatest trick in the history of humanity, I think, or in the history of business anyway, when they convinced people that the retail side of Amazon was underwriting AWS. And finally, due to activist shareholders, they had to divulge where they were actually making money. Surprise, AWS is underwriting a war on Walmart. That's what's actually happening. And it's like, yeah, Bezos, one smart motherfucker. And that they shouldn't censor that out because that's total praise. And Bezos saw what we saw, which is like, actually, this is a pretty good business. And so our pricing is basically an EC2 pricing, but you consume a lot less. You consume a lot less because you're only spinning up containers that correspond to what you're actually doing. So we think it's a win. We are not going to be the only ones to do this. Other people are going to figure this out too. Containers on bare metal is a huge win. In terms of I want to speak to the upstack landscape just for a second, because you'd be forgiven to be like, wow, the container landscape seems extremely complicated. And it is. There are so many things going on. You've got Kubernetes, you've got Mesos, you've got Docker, you've got Swarm, and everyone's like, oh my God, I just okay, please, no more frameworks. And they're like, hey, we have Nomad now from HashiCorp. You're like, no, please, don't. It's awesome, but no, please, delete it. And because these things are all open source. They're all open source. And if there's a fallacy right now, the fallacy is that it's going to be winner take all. It is not going to be winner take all. We are in an all open source world. Triton is all open source, SDC is all open source, SmartOS is open source, Kubernetes is open source, Docker is all open source, Mesos is all open source. It is all open source. It won't be winner take all. It's going to be mutation take all. You're going to have mutations everywhere, and I think it's going to be a good thing. It's going to be challenging in a lot of ways, but I think it's going to be great. It's going to allow us to use the right tool for the job in various places. With Triton, we've taken a very modular approach. We're trying to be that lowest layer, but you're going to see a bunch of upstack stuff going on, and just don't think to yourself, wow, I need to pick who's going to win. Who's going to be the next VMware? There might not be a next VMware. Funny story. Like, don't tell this to you go to Silicon Valley and say this, and a VC is going to barf into their lunch. It's like, I just funded the next VMware. It's like, well, you might not have, actually, funnily enough. You might have funded the next acqui-hire, actually. But there might not be a next VMware because we might not take all of the money being spent on IT and consolidate that into a beautiful campus in Palo Alto, which VMware's campus is very, very beautiful. Too beautiful, actually. Never bring a customer to that campus. They're like, I'm paying for mowing the lawns? Yes, you are. But let's not phrase it like that. What we might do instead is actually reallocate capital in a very different way, where we are actually using it inside of an organization. So I think it's unlikely to be winner take all. You're going to get a lot of productive mutation. We think that this spreads far beyond traditional computing. It changes the way we think of all elements of the stack. We developed a container-centric object store called Manta that we love and use, but is still in the future. All open source, but still in the future, because people are still kind of grokking containers. But it allows you to, it's like S3, but you can spin up a container on your objects. Pretty cool. So in terms of the future of containers, we've believed in OS-based virtualization for a very, very, very long time. With the rise of Docker, this is not controversial, which is great. But in order to achieve the full promise, in order to not kill the kittens that guest OS does, in order to not melt the ice caps from unused DRAM, we need to run containers on the metal. That is the end state. No question we're going to be running containers on the metal. So the question is, how do we get there? Again, unlikely winner take all. But when we run them on the metal, we get rid of that VM, that vestigial abstraction, that 1401 abstraction. We get rid of that abstraction. It allows us to no longer think in terms of allocating things, allocating VMs, but consuming things, consuming containers. And again, Triton represents our belief that containers don't have to compromise multi-tenant security, operational elasticity, on the metal performance. You can have all three. With that, thank you very much.